What is up, everybody? It's Miss Brothers. Hey, let's do practice number 6. This is our first crack at two-step conversions. All right. Again, you guys, just a quick reminder, the reason we spend all this time working on these conversions is right now we are in Unit 7, and as we go into Units 8 and 9, we're going to start doing problems that require and lab work that requires quite a bit of these conversions to take place. So Unit 7 is all about introducing the idea of moles and how we use moles in these conversions. Okay, so that's why we're doing all this. Now, unlike the first set of conversions, we're actually doing what we call two-step conversions, because unlike our first practices, we just had to do one step where we were converting either particles or mass or volume to moles or moles back. In this case, you guys, what we're doing are conversions where there's not one direct step, where we have to do a little middle step in order to get the answer. So in these, you guys, like on this first one, we are jumping from, we have to find out the mass if we are given particles. In this case, the particles are molecules, okay? There's no direct jump. There's no direct conversion factor that we can use to get from mass to particles. So as you saw in your notes, the rule is we must convert to moles first. Because if we convert to moles first, we can first do particles to moles, and then we can do moles to mass. So we have to do that extra step. So let's get to work on these problems, and hopefully this will kind of help show you the process. So like I always do, I always start with what I have to find. I have to find mass, which means that my final unit, when I write my answer and circle it, the unit that I should end up with is grams. Okay? So I'm starting out with particles. Let's go ahead and write out what I'm starting with. 3.0 times 10 to the 23rd particles, or in this case, I'm going to put molecules of Cl2. Okay? I'm going to set that over 1. Now, if you remember from your instructions, what we know is that we have to convert to moles first, which means this has to go on top. Moles of Cl2 has to be first. And remember, we have to be able to cancel out the unit of molecules of Cl2. And if you remember from our practices, if we're going to go from moles to particles, that equivalency is 6.02 times 10 to the 23rd molecules of Cl2. Now, like I said, we can't do a direct jump from particles to mass, which means that we're going to throw on an extra T-chart here, but we'll get to that in a minute. Now, me personally, when I'm setting this up, I actually really like to cancel my units before I set up the next part of my problem. So I'm just going to go ahead and do that now. Now the only unit that's left is moles. Now I can go from moles to molecules, so I'm going to go ahead and do that. Or I can go from moles to mass. So I'm going to put 1 mole of Cl2 down here. Now, if I'm going to find, remember, my final unit has to be grams. So we know that's going to have to go up there. And I don't have an equivalency. Like if I'm using volume, I would just fill in 22.4. Or if I was trying to find particles, I would just fill in 6.02 times 10 to the 23rd. But I can't do that with mass. Remember, you guys, I have to go to the periodic table, and I have to look up the masses in order to calculate the mass of this molecule of Cl2. So I'm going to go up here, and I'm going to do my calculations up here. I've got chlorine, which is Cl. I've got 2 of those because that subscript means I have 2. And if I were to look it up, I would know that the mass of chlorine is 35.45 grams. Now remember, I have to take this times 2, which is going to equal 70.90 grams. And that's the number that I'm going to put in right here. 70. Oops, I did that wrong. 70.90 grams. So now I can cancel out 1 mole of chlorine here and 1 mole of chlorine here. And now it's just a matter of setting up my multiplication. Now I always set up, because I'm doing an extra step, I really like to set up my multiplication at this end. So I'm going to go ahead and give myself a little room to do that. 3.0 times 10 to the 23rd times 70.90 grams of Cl2 over 6.02 times 10 to the 23rd. Now I'm going to give myself a little bit of room, so I'm just going to draw a line so I can more easily do this. Now what I'm going to do, one of the things you have to remember when you're doing these problems, do your multiplication in total first. Okay, so what I'm going to do is I'm going to bring my calculator up here, and I'm going to type in 3.0 EE, my EE button to the 23rd, and I'm going to multiply that, so times 70.90. Now this is the important thing. Hit the equal sign first. Equals 2.127 times 10 to the 25th. Now that we have that number, now we can divide by Avogadro's number right here. So now we're going to take our answer and we're going to divide that by 6.02 EE to the 23rd equals, and that's going to give me my final answer, which is going to be 35.33. And again, remember, this is the unit that I have right here, grams of chlorine gas. That is going to be your final answer right there. So like I said, you guys, the most important thing you can do when you're doing this portion of is to do your multiplication first, hit your equal sign, get the answer, and then do your division. Okay? Let's do the next one. So we're trying to find the volume in liters. So we know that our final unit is going to be liters. We need to know what is the volume in liters occupied by 16.3 grams of ammonia. So we're going to start with a mass, and we have to get the liters. And again, I can't do a direct conversion, which means I'm going to have to make sure that I do my moles first. So let's start with what we're given, 16.3 grams of NH3. We're going to set that over 1. Now again, you guys, I have to solve for moles first. So I'm going to put 1 mole of NH3 first, because these moles are going to act as the bridge sort of between grams and liters. All right? So I know that grams has to be down here, grams of NH3, but I might not quite know what my mass is. I have to calculate the mass of this. And so I'm going to come up here, and I've got nitrogen. I've got 1 nitrogen, and I know that the mass of nitrogen is 14.01 grams. I've got, notice this, 3 hydrogens. So I've got hydrogen times 3 equals 3.03. And what I end up with there, if I add it together, is 17.04 grams. That's my mass of NH3. So I'm going to put that right there, 17.04. I'm going to erase that because I'm going to run out of room here if I don't. So we're just going to get that out of the way. We've managed to calculate that. And like I said, before I set up my next portion of this, before I set it up so that I can solve for volume, I like to get rid of my current units that I can get rid of. So I'm going to get rid of grams of NH3, grams of NH3, and that leaves moles, which is where I want. Now I have to finish in liters, so I know that my final unit has to be liters. I'm going to put 1 mole down here so I can cancel it. And if you remember, when we are dealing with volumes, if I have a mole of any gas, it equals 22.4 liters of NH3 in this case. Now I'm set up. I just have to do my canceling. I'm going to cancel 1 mole here and 1 mole here. And now I can set up my multiplication. So I've got 6.3 over here. I'm sorry, 16.3. Whew, that would have been a bad one. 16.3. I'm going to multiply that times 22.4 liters of NH3. And I'm going to take that over 17.04. So let's go ahead and crunch that out in my calculator. Remember, I'm going to do my multiplication first. So I've got 16.3 times 22.4 equals 365.12. Now that I have my answer, now I can do my division. Divided by 17.04 equals So I've got 21.42, and I can round that 7. That 7's going to allow me to round this to 21.43. So this is going to equal, here I'm going to make myself a little bit more room there, equals 21.43 liters of NH3. And that is what I can circle right there. Good, we're cruising along. Let's do number 3. I want to figure out how many molecules, so I have to figure out the number of molecules in 8 grams of methane. So I'm essentially going from grams to molecules, which means I have to do my extra step, finding my moles first. So let's go ahead and set this up. I have 8.0 grams of methane, which is CH4, over 1. I have to be able to go from moles to grams, so I'm going to set up 1 mole over here of CH4. And down here, I know that I have to be able to cancel grams away, so I'm going to set up grams of CH4 right here. And remember, you guys, because I'm dealing with moles and mass, it means I have to figure out the mass of this molecule of CH4. So here I go. I've got carbon times 1, which is 14 point, no, I'm thinking of nitrogen. This one is 12.01. I've got 4 hydrogens, so I've got hydrogen times 4, which is going to be 4.04. And if I add this up, I've got, there's 5, there's 0, there's 6, there's 16.05 grams. That's the number I'm going to put down here because that is the mass of 1 molecule of CH4, so this can be 16.05 grams. I'm going to erase that so I have enough room to work. Now before I move on, I'm going to go ahead and cancel out the units that I can cancel. So grams, grams. I'm going to set up the rest of my T-chart. I'm trying to get to molecules, so I know that I have to put 1 mole of CH4 right down here. And because molecules are a particle, and if I'm doing moles to particles, I know that 1 mole is equivalent to 6.02 times 10 to the 23rd molecules of methane CH4. Okay. Now I'm in a position to cancel moles, canceling moles, and now I can do my set up my multiplication. I've got 8.0 times 6.02 times 10 to the 23rd molecules. Don't forget those units. And don't forget that substance of CH4 over 16.05. So if I put that into my calculator, I'm going to have 8.0 times 6.02, hit your EE button, 23, equals, notice I'm getting that equal sign, so I end up with 4.186 times 10 to the 24th, divided by 16.05, and that's going to leave us an answer of, which is essentially 3.00 times 10 to the 23rd, and that's going to be molecules of CH4. And that is the answer that I will circle. Again, you guys, it's really important to me that you're circling your answers, because if you look at this problem, there's a bunch of stuff going on. When you circle the answer, it allows you and it allows me to see your final answer while at the same time being able to see the work you've done, the T-chart, your canceling, which are all those things that I'm looking for. Okay? Let's do number 4. So I want to know how many grams. So again, you guys, this is a mass. My final unit should be in grams. I start with 33.6 liters of carbon dioxide at standard temperature and pressure, which is where we're going to start this problem. 33.6 liters, that's the unit we are given. And specifically, that's CO2. I'm going to set that up over 1. I know that I'm going to have to cancel out liters. I know that I have to solve for moles first because that's what my notes tell me. So I'm going to go ahead and set this up. The equivalent, again, I'm dealing with liters here. And if you remember, If I have 1 mole of any gas, that means I have 22.4 liters of that gas. In this case, the gas is CO2. So I'm going to put my substance there. I know I have to add to my T-chart. I'm not quite done yet. But before I do that, I'm going to go ahead and cancel out carbon dioxide here, carbon dioxide here. I'm going to set my moles down here because I know I have to cancel moles. And remember, you guys, I am trying to finish with grams, which means I'm going to end up with grams of CO2 up here. But again, you guys, because I'm dealing with mass, it means I have to go to the periodic table and I have to figure out, I have to add up my molar mass. So I've got a carbon times 1 equals 412.01 grams. I've got 2 oxygen, so oxygen times 2 equals 32.00 grams. And if I add that up, that's going to give me 44.01. And that's the quantity I'm going to fill in right here, 44.01 grams of CO2 in 1 mole of CO2. Let's erase. And then let's go ahead and do our canceling next. Cancel out our mole of CO2 here and our 1 mole of CO2 here. And let's set up our multiplication across my T-chart. So I've got 33.6 times 44.01 grams of CO2 over 22.4. I'm going to grab the handy calculator, the 30XA Solar. I do like this calculator. And I'm going to go ahead and type in 33.6 times 44.01. That equals 1,478.736, and we are going to divide that by 22.4. And that's going to give us a grand total of 66.02. I am using that 5 to allow that 1 to round up to a 2. Don't forget your units. This is going to be grams of CO2. And that is going to be your final answer for question number 4. All right, let's do number 5. You guys, I'm going to go ahead and go through all of these. I have had some requests to do all the problems. And again, at any point, if you feel like you have the hang of it, you certainly don't have to watch this whole thing, okay? All right, next. I want to know what the mass is. Now, remember, you guys, if I have mass, it means my final unit needs to be in grams if I have 44 liters of oxygen gas at STP. So for this one, I'm going from liters to mass. So I have 44 liters of O2. I know I'm going to have to be able to cancel out liters of O2. I know that I have to solve for moles of O2. And because I'm dealing with moles in volume, I know that no matter what the gas is, 1 mole of that gas is going to be 22.4 liters. Let's take a second to cancel out our units of liters of O2. I've got then 1 mole that I'm going to put down here of O2. And again, I'm trying to find the mass in grams of O2. So I'm going to go ahead and throw my unit on there because I know that's what I have to get to. And again, you guys, I have to find that molar mass. So I've got 2 oxygens. Oxygen times 2. Remember, oxygen has an atomic mass of 16. So 16 times 2 means we're going to have 32.00 grams. And that's what I'm going to put right there. I'm now in a position to cancel out moles of O2. I shall erase, get that out of the way. Set up my multiplication, 44 times 32.00 grams of O2 over 22.4. Again, doing our multiplication first, 44 times 32.00. Hitting that equal sign, I get the quantity of 1,408 grams of O2 divided by then 22.4 equals 62.86. Because again, you guys, I'm going to make sure that that 7 allows that 5 to round up to a 6. So my final answer here is going to be 62.86 grams of O2 gas. And we are ready for number 6. How many molecules? So I know that my final answer is going to be the unit of molecule. I start with 68.43 grams of H2O. Let's go ahead and get it set up. You know what to do. I'm given the unit of grams, so 68.43 grams. I have to solve for moles, which means I'm going to have to take moles specifically. Oops, I have to put that down. H2O, don't forget the substance. 1 mole of H2O. I know this has to be grams of H2O down here because I have to be able to cancel grams, which means I have to take a second and I have to calculate the molar mass of H2O or water. So I've got hydrogen times 2 equals 2.02. I've got oxygen times 1 equals 16.00, which means that molar mass is going to be 18.02 grams. And you'll get to the point, you guys, where you'll do this enough where you won't even have to calculate it anymore. You're just going to be like, oh yeah, the molar mass of water is 18.02 grams. It's a fun day when that happens. Anyway, we're in a position now where we can cancel our units. Grams of H2O, grams of H2O. So the only unit left is the mole of H2O. So I know I'm going to have mole of H2O down here so I can do my canceling. And I'm trying to find molecules. And again, you guys, molecules is a particle. So this is going to be molecules of H2O. So 1 mole of any particle is going to be 6.02 times 10 to the 23rd of that particle. I'm now in a position to cancel moles. So now I can set up my multiplication. 68.43 times, and again, you guys, I really love multiplying with parentheses. That's just a thing for me. There's lots of ways to multiply. I think parentheses is great because it helps you kind of contain all those quantities. Times 6.02 times 10 to the 23rd molecules of H2O over this quantity 18.02. So let's load that into the calculator. I've got 68.43 times 6.02. Hit that EE button to the 23rd. Make sure you hit your equal sign. Now that we have this answer, now we're ready to do our division. Divided by 18.02 equals, and if I'm doing my rounding here, this is going to be 2.29 molecules of H2O, and that is the quantity that I'm going to end up putting my circle around. That looks good. Make sure I did my work here. So 2.2. Oh, you know what? I did the exponent wrong on that. Boop. I totally did the exponent wrong on that. Sorry, you guys. That's 2.29 times 10 to the 24th molecules of H2O. Sorry about that. That could have been awkward. Whew. Caught myself. Alright, let's see. Now I'm just checking to see if I did that back here. Yes, I did that right there. Okay, good. Let's keep going. Getting so close to being done. Alright, I need to know how many liters of methane. So I know my final unit's going to be that capital L of methane, which is CH4, if I start with 15.85 grams of methane. So let's so we're essentially, you guys, we're going from grams, we have to finish with liters. So 15.85 grams of methane, CH4. And we're going to do that over 1. I know I have to convert to moles of CH4. Now, if memory serves, I actually had CH4 up here somewhere before, didn't I? Which one was the methane? Molecules, methane. There it is. So I know that my molar mass of methane, I already know that I'm just going to cheat and use that. 16. It's not really cheating. It's being efficient. It's my story, and I'm sticking to it. It's totally being efficient. All right. So I have 15.85 over here grams of CH4. I have 16.05 grams of CH4 right here. So now I can go ahead and cancel my grams of methane out, which leaves 1 mole of methane, which means I have to cancel that out next. So I have to go ahead and get that in here. And again, you guys, I'm trying to finish with liters, so I know that I'm going to finish. My answer is going to have liters of CH4. If I have 1 mole of CH4, that means that that occupies a space of 22.4 liters. And now I'm in a position to cancel these units. And I can set up my multiplication, 15.85. Oops, that's not a unit. I don't have a unit in that number. Times 22.4 liters of CH4 over, it's kind of sloppy. I need to be less sloppy. I'm doing that again. 0.4 liters of CH4, close the parentheses, and we're going to put that quantity of 16.05 down at the bottom. Bring back the calculator. There it is. 15.85 times 22.4 equals 355.04 divided by 16.05 equals 21.12 liters of methane, otherwise known as CH4. And that's going to be your final answer. Cool. Last one. Let's do it. I want to know how many liters. So again, you guys, my final unit should be that capital L of water vapor, H2O, that are present in 16 grams. Okay. So we've got 16.0 grams of H2O. And again, my first step is always to convert to moles first of H2O. I know I have to be able to cancel out grams, so I'm going to set that up, grams of H2O. And I'm pretty sure I had water earlier, didn't I? Which problem was it? Which problem was it? It's that problem over there. Well, I already know that if I'm dealing with water, I know the molar mass of water is 18.02 grams. So I'm just going to use that. I'm going to take a second to cancel out my grams of water. So that way the only thing left is my moles of water. I'm going to set up moles down here so I can cancel it. 1 mole of H2O. And I know, you guys, that I have to end with liters of H2O. Okay. And I also know that if I have a mole of any gas, that gas occupies a space of 22.4 liters. So I'm nice and set up. Now I'm in a position to cancel here, cancel here. Let's set up that multiplication. So I've got 16.0 times 22.4 liters of H2O over 18.02. Let's go ahead and do some math there. I have 16 times 22.4 equals 358.4 divided by 18.02, and that leaves me with 19.89 liters of H2O, and that is where I'm going to finish out my problems. Alright, so again, you guys, the two-step problems, essentially what you're doing is you're doing 2 separate problems in one handy T-chart. And again, you guys, as we get to units 8 and 9, there's a couple of things I want to make sure that you remember. Number 1, make sure you include your units throughout. And number 2, you need to make sure that you're including your substances. Right now, you guys, we're doing 2-step problems in which you're using the same substance throughout. So water in this problem or methane here. But when or ammonia right here, but as we get into these problems and these units and we start balancing equations, you're actually going to be coming up against problems like this where you're dealing with different substances. So instead of doing 2-step, we end up doing 3-step and sometimes 4-step problems. So it becomes even more important to make sure that as you do these problems that you're remembering to do your units and your substances. And that's why this process, I know it's annoying, it becomes a really big deal, being able to go through and do your canceling and making sure you're canceling your units or your substances. But chemistry can get a little messy, and so we work to do things to try to make it at least a little bit clearer. All right, you guys, if you have questions about the 2-step process, by all means, let me know. I would love to answer your questions. All right, you guys, have a great day.